In this video, we're going to look at the divisibility of numbers and find a couple of surprising results. Let's just think about the positive counting numbers 1, 2, 3, 4, 5 and so on. These are called the natural numbers, and we've even got this special symbol to represent natural numbers. Now the properties that we're going to look at in this video also work on negative counting numbers, but let's not worry about that for now. What proportion of the natural numbers are divisible by 2? Well, every other number is a multiple of 2. 2, 4, 6, 8, 10 and so on. So a half of the natural numbers are divisible by 2. If you were to pick a natural number at random, half the time you'd pick one that's divisible by 2 and the other half of the time you'd pick one that's not divisible by 2. Okay, let's think about what proportion of numbers are divisible by 3. Well, every third number is a multiple of 3, so a third of numbers are divisible by 3. If I asked everyone watching this video to pick a natural number at random, a third of you would have picked a number that's divisible by 3. And we can also see that a quarter of the natural numbers are divisible by 4, a fifth of them are divisible by 5, and so on. So let's try an experiment. To be honest, this works best if you're in a group of 30 or more people, and maybe some of you are, in a classroom for example. You're going to need a calculator, so if you haven't got one, pause the video now and go and get one. Right, so I want you to choose a random 3-digit number. For example, 123, although I'm sure you'll come up with something much more imaginative than that. Now type it into your calculator. Now to make this a bit more interesting with bigger numbers, I want you to repeat those 3 digits to make a 6-digit number. So my 123 becomes 123, 123 for example. And now we've got a random 6-digit natural number. Now half of you should have a number that's divisible by 2, a third of you have a number that's divisible by 3, a quarter of you have a number that's divisible by 4, and so on. But what proportion of you will have a number that's divisible by 7? Is it a seventh? Well, try dividing your 6-digit number by 7. Is the answer a whole number? I bet it is for all of you. So that proportion is 1. 100%. All of you have a number that's divisible by 7. Okay, clear your calculator and type in that 6-digit number again. What proportion of you have got a number that's divisible by 91? So divide that number by 91 and see if you get a whole number answer. You'd think the answer would be a 91th, about 1%, but the proportion is 1. 100%. All of you should have a number that's divisible by 91. Right, one last go. Clear your calculator, type in that 6-digit number again, and the new question is, what proportion of you have a number that's divisible by 143? Well, it should be 143rd of you, just over half of 1%. But divide that number by 143 and I think all of you will get a whole number answer. The proportion is 1, 100%, all of you. So why are our divisibility proportions breaking down? It's weird, eh? Well, maybe not. Let's think about what happened when I told you to repeat your random 3 digits to make a new 6-digit random number. So we start off with our 3-digit number. In my case, 1 was in the hundreds column, 2 was in the tens column, and 3 was in the ones column. If I multiply that by 1,000, I get 123,000. 1,000 times 100 is 100,000, 1,000 times 10 is 10,000, and 1,000 times 1 is 1,000. So all those digits have moved to columns who have a place value 1,000 times bigger. Now if I add my original number again, I get 123,123. So what I've done is taken my original number, multiplied it by 1,000, and then added another one. I've got 1,001 of those numbers. What I've done is multiply my original number by 1,001. This means that the innocent sounding repeat those digits actually means multiply your number by 1,001. Now let's take a quick diversion. You've probably heard of prime numbers. They're natural numbers that have got exactly 2 factors. You may have used the definition that they are numbers which are divisible by only 1 and themselves, but be careful, because 1 isn't a prime number because it's only got one factor, 1. So the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, and so on. Now you may be surprised to learn that all natural numbers greater than 1 can be expressed as the product of some prime numbers. For example, 210, and 2 times 105 equals 210, and 2 is a prime number, remember. And 105 can be expressed as 3 times 35, and 3 is a prime number. And 35 is 5 times 7, and both 5 and 7 are prime numbers. So 2 times 3 times 5 times 7 is 210. And we call 2 times 3 times 5 times 7 the product of primes for 210. Now the slightly surprising thing is, no matter what number you start off with, you can always find a bunch of prime numbers that will multiply together to make that number, so long as you start off with a whole number greater than 1. Let's do the same for 1001. Well, 7 times 143 is 1001, and 7 is a prime number. And 11 times 13 is 143, and they're also both prime numbers. So 7 times 11 times 13 equals 1001. They're the product of primes for 1001. Now if we think back to our 6-digit number, which is 1001 times our 3-digit number, we can write it out like this. With 1001 being equal to 7 times 11 times 13, we can replace the 1001 with 7 times 11 times 13. Now hopefully we can see that our 6-digit number is definitely divisible by 7 because it's 7 times whatever this bit is. So that's how I knew all of your numbers were going to be divisible by 7. But multiplication is commutative, which is just a fancy way of saying that we'll get the same answer no matter which order we multiply our numbers together in. So instead of writing 7 times 11 times 13 times 123, I could write 7 times 13 times 11 times 123. And since 7 times 13 is equal to 91, I knew your 6-digit number was equivalent to 91 times something. In other words, it was divisible by 91. Or I could have multiplied the 13 and the 11 together to get 143, and that told me that your number was divisible by 143. So using a little bit of maths knowledge and our analytical skills, we've cleared up our little mystery. By thinking carefully about what mathematical operations we needed to apply to get to the 6-digit number from our original 3-digit random number, we could see that we were just multiplying it by 1001. And by using the fact that all natural numbers greater than 1 can be expressed as a product of primes, we can say that 1001 is equivalent to 7 times 11 times 13. And by combining those prime factors in different ways, we can see that our 6-digit numbers would all be divisible by 7, 11, 13, and 7 times 11, so 77, and 7 times 13, so 91, and 11 times 13, so 143, and of course 7 times 11 times 13, which is 1001. Then I carefully chose those numbers for you to test the divisibility, so I knew they'd all be factors of all of your numbers. If I'd picked any other factors to test, then the normal divisibility proportions would have applied. If I'd have picked 12, then only a 12th of you would have had numbers divisible by 12. If I'd picked 142, then only 142th of you would have had numbers divisible by 142. So this surprising divisibility isn't so surprising after all. When you subscribe to our channel, remember to click the bell to ensure you get notifications about our new videos. And for more mathematics content, why not follow the link in the description below to nagwa.com.